Good morning, students. Welcome back to the study of P block elements concept. This is part number 2. In part number 1, we studied group number 13 elements, boron family, the occurrence of the element. We studied some periodic properties of group number 13 elements. We'll continue with the study of group number 13 elements, that's a boron family. In this class, let us discuss some physical properties of group number 13. The elements present in group number 13 are boron, aluminium, gallium, indium, thallium, and neodymium. The first member of the group boron being a non-metallic in nature, hence it is extremely hard and it's a black colored solid. And this boron exists in many allotropic forms. Allotropic forms are the different forms of the boron which are chemically same but physically they have different properties. Boron do exist in many allotropic forms. Due to very strong crystalline structure, crystalline lattice, boron has unusually very higher melting point. Okay, boron is non-metallic, hard in nature, black colored solid it is found in many allotropic forms, and due to its strong crystal structure, it has very high melting point. Whereas other members andre aluminium, gallium, indium, thallium are metallic in nature. Boron is non-metallic, whereas other members are metallic. They are soft metals with a low melting point and high electrical conductivity. Okay, so since they are metallic in nature, they conduct heat and electricity. They are good conductors. In these metals, gallium has very low melting point of only 303 Kelvin. That means around it's 30 degrees Celsius. And this gallium could exist in liquid state during summer season. Because of its 303 Kelvin, it present in a liquid state in summer season, whereas in winter seasons, it's present in a solid state. Even though it has a very low melting point, but boiling point of gallium is very high, which is 2676 Kelvin. Because of this nature, gallium is useful for measuring very high temperatures. Okay, these are very few physical properties that are mentioned in your book. We'll see some chemical properties of boron family. First one, oxidation state and trends in chemical reactivity. Just recall your memory about my previous class. The electronic general valence electronic configuration of group number 13 is ns2 np1, isn't it? How many valence electrons are there? ns2 np1. Total 3 valence electrons are there. ns ದಲ್ಲಿ 2 electron ಇದಾವೆ, np ದಲ್ಲಿ 1 electron ಇದಾವೆ. ಇದೆ ಹೌದಾ? ಅಂದ್ರೆ ಟೋಟಲ್ ಆಗಿ 3 ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದಾವೆ. ಇದನ್ನ ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ರಿ. First member, boron. Due to its small size, boron has higher ionization enthalpy. Okay, when the size is small, ionization enthalpy will be very high. We know, we studied this concept in periodic table lesson, isn't it? Because of smaller size, the removal of outermost or valence electron becomes very difficult. Therefore, it requires higher energy. Hence, ionization enthalpy is very high. Therefore, boron forms covalent compounds. Boron do form oxidation state of +3 whenever it react with other elements. But as we move down from boron to aluminium, boron ದಿಂದ aluminium ಹೋದಾಗೆಲ್ಲ size ಏನಾಗ್ತದೆ? Increase ಆಗ್ತದೆ. As the size increases, the ionization enthalpy considerably decreases. Therefore, Compared to boron, aluminium has considerably decreased lesser ionization enthalpy and is therefore able to form Al plus 3 ions. Okay, boron kintanu aluminium Al plus 3 ions na easyagi form ಮಾಡ್ತದೆ. ಅಂದ್ರೆ NH2 and NP1, all the three electrons, if they involve in a chemical bond formation, chemical reaction, then aluminium will exist in a Al plus 3 oxidation state. But when you move down the group, aluminium ಮತ್ತು ಅದಕ್ಕಿಂತ ಕೆಳಗಡೆ ಹೋದಾಗೆಲ್ಲ, due to poor shielding effect, poor screening effect, this effect we discussed in previous class, isn't it? So when you move down, as the d and f orbital starts filling, the d electrons and f electron will show a poor screening or poor shielding effect. Therefore, the increased effective nuclear charge holds ns electron tightly. Okay, so ಇದನ್ನ ನೆನಪಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ಏನಾಗ್ತದೆ, when the shielding effect is low between the nucleus and the outermost electron due to d and f orbitals, the nucleus will hold ns electron tightly. ನ್ಯೂಕ್ಲಿಯಸ್ ಏನು ಮಾಡ್ತದೆ, ಔಟರ್ ಮೋಸ್ಟ್ ಎನ್ ಎಸ್ ಶೆಲ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡಿಬಿಡ್ತದೆ, ಎನ್ ಎಸ್ ಎಲೆಕ್ಟ್ರಾನ್ನ ಟೈಟ್ ಆಗಿ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತದೆ. ದಟ್ ಎಫೆಕ್ಟ್ ಈಸ್ ನೋನ್ ಆಸ್ ವಾಟ್, ಇನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್. ಓಕೆ, ಸೊ ಇನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್ ಇನ್ನೂ ಡೀಟೇಲ್ ಆಗಿ ನೋಡೋದಾದ್ರೆ, ವಾಟ್ಸ್ ಇನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್? ಇಟ್ ಈಸ್ ದ ಟೆಂಡೆನ್ಸಿ ಆಫ್ two electrons in the outermost atomic s orbitals. Okay, so inert pair effect, how we are going to explain this or define this? It's a tendency of two electrons in the valence s orbital to remain unionized or unshared in a compounds of post transition metals. Post transition metals andre ಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಡಿ ಎಲಿಮೆಂಟ್ಸ್ ಆದ ನಂತರ ಬರೋ ಎಲಿಮೆಂಟ್ಸ್ ಏನಂತವೆ, ಪೋಸ್ಟ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್. ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್. ಓಕೆ, ಸೊ ಯಾವ್ಯಾವುದು? ಗ್ಯಾಲಿಯಂ 31. ಸೊ 30 ಯಾವುದಿದೆ? ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಇದೆ. ಅಂದರೆ ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಥ್ಯಾಲಿಯಂ ಆ್ಯಂಡ್ ಸೋ ಆನ್ ಆರ್ post transition element. These elements comes after d block elements. Okay, so d block element ಆದ್ಮೇಲೆ ಬರ್ತವೆ. ಓಕೆ, ಈ post transition elements though ns electrons, no, so they do not take part in a chemical bond formation, they do not undergo ionization, they remain unionized, they remain unshared with other compounds. Okay, ಅಂದ್ರೆ ಪೋಸ್ಟ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದರೆ ಯಾವುದು? ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಸೋ ಆನ್. ಅದರಲ್ಲಿ ಏನಾಗ್ತದೆ, ಡ್ಯೂ ಟು ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್, ದ ಎನ್ ಎಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಡು ನಾಟ್ ಟೇಕ್ ಪಾರ್ಟ್ ಇನ್ ಅ ಕೆಮಿಕಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್. ಸೊ ದಟ್ ಎಫೆಕ್ಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ವಾಟ್? ಇನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್. ಓಕೆ, ಈಗ ವಾಪಸ್ ಬರೋಣ. ಏನಾಗ್ತದೆ, ವೆನ್ ಯು ಮೂವ್ ಡೌನ್, ಗ್ಯಾಲಿಯಂ ಆದಮೇಲೆ ಗ್ಯಾಲಿಯಂದಿಂದ poor shielding effect of d and f electrons orbitals is there, therefore the nucleus will hold ns electron tightly. Okay, ಆ ಎಫೆಕ್ಟ್ ಏನಂತೇವೆ? inert pair effect, and thereby restricting their participation in bonding. Okay, so ಈಗ inert pair effect ಅಂದ್ರೆ ಏನು? ns electron, two electrons of s orbital are not available, they are not involved in a chemical bond formation. ಓಕೆ, ಅದೇನು ಇನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್. ಅವಾಗ ಎನ್ ಎಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೆಮಿಕಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ದಲ್ಲಿ ಯೂಸ್ ಆಗೋದಿಲ್ಲ. ಹಾಗಾದರೆ ಯಾವುದು ಉಳಿತು? ಓನ್ಲಿ ಎನ್ ಪಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಹಾಗಾದರೆ ಎನ್ ಪಿ ಎಲೆಕ್ಟ್ರಾನ್, NP1, ಓನ್ಲಿ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ವಾಲ್ವ್ ಆತಂದರೆ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ತೋರಿಸ್ತದೆ? ಇಲ್ಲ, ಅದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಆಫ್ ದಿಸ್, ಓನ್ಲಿ p ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇ ಬಿ ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ಬಾಂಡಿಂಗ್. p ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದರೆ NH2 NP1. ns electrons are less available, ns2 electrons are less available. ಹಾಗಾದ್ರೆ ಯಾವ್ದು ಅವೈಲೇಬಲ್ ಆಯಿತು? ಓನ್ಲಿ NP, ಓನ್ಲಿ p ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ NP1, ಒಂದೇ ಎಲೆಕ್ಟ್ರಾನು ಸಿಗ್ತದೆ ಬಾಂಡಿಂಗ್ ಆಗಲಿಕ್ಕೆ. ದೇರ್ಫೋರ್ when you move down, the tendency to show +3 oxidation state decreases and the tendency to show +1 oxidation state increases. ನೋಡ್ರಿ ಏನಾಗ್ತದೆ, ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಥ್ಯಾಲಿಯಂ. ಸೊ ದೇ ಶೋ +1 +3 ಎರಡು ತೋರಿಸ್ತದೆ. ಬೋತ್ NS and NP electrons are involved, but the tendency to exhibit +3 go on decreases. ಯಾಕೆ? ಡ್ಯೂ ಟು inert pair effect. Both +1 and +3 oxidation states are observed, but look at the last line. This point is very important. The relative stability of +1 oxidation state progressively increases for heavier member. ಅಲ್ಯೂಮಿನಿಯಂದಿಂದ ಗ್ಯಾಲಿಯಂಗೆ ಜಾಸ್ತಿ ಆಯಿತು, ಗ್ಯಾಲಿಯಂದಿಂದ ಇಂಡಿಯಂಗೆ, ಇಂಡಿಯಂದಿಂದ ಥ್ಯಾಲಿಯಂಗೆ ಜಾಸ್ತಿ ಆಯಿತು. ಏನು ಜಾಸ್ತಿ ಆಯಿತು? ದ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ +1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಓಕೆ, ಹಾಗಾದರೆ ಕನ್ಕ್ಲೂಷನ್ ಏನು ಮಾಡೋಣ? ಬೋರಾನ್ ಬೀಯಿಂಗ್ ಅ ನಾನ್ ಮೆಟಾಲಿಕ್ ಇನ್ ನೇಚರ್. ಓಕೆ, ಸೊ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬಹಳ ಕಡಿಮೆ ತೋರಿಸ್ತದೆ. ಅಲ್ಯೂಮಿನಿಯಂ ಶೋ +3, ಬಟ್ ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಥ್ಯಾಲಿಯಂ ದೇ ಶೋ ಬೋತ್ +1 ಆ್ಯಂಡ್ +3, ಬಟ್ ದ +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಟೆಂಡೆನ್ಸಿ ಕಡಿಮೆ ಇರ್ತದೆ, +1ದ್ದು ಜಾಸ್ತಿ ಇರ್ತದೆ ಡ್ಯೂ ಟು ಇನ್ನರ್ಟ್ ಪೇರ್ ಎಫೆಕ್ಟ್. In your model question paper, whatever the question paper which is given for you as an assignment, no, in the model question paper number 2 chemistry question number 7 ಆ ಪ್ರಶ್ನೆ ಈ ರೀತಿ ಇದೆ: the stability of +1 oxidation state in group number 13 increases down the group Y. Okay, so last line ಬಗ್ಗೆನೇ ಹೇಳ್ತದೆ. So when you move down, +1 oxidation state stability increases. ನಿಮ್ಮ ಆನ್ಸರ್ ಏನು? This is the answer. When you move down, there will be, due to the poor shielding effect, we come across inert pair effect. Okay, so inert pair effect ಅನ್ನೋದು ಒಂದು ವರ್ಡ್ ಬಂದ್ಬಿಟ್ರೆ ಸಾಕು, ಇದೇ ನಮ್ದು ಆನ್ಸರ್. ಓಕೆ, ಸೊ ಈ ವರ್ಡ್ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಡ್ಯೂ ಟು inert pair effect in a heavier member like thallium, aluminum, gallium, thallium, indium. ಅಂದರೆ when you move down in the group number 13, the stability of +1 oxidation state go on increases due to inert pair effect. Okay, inert pair effect ಅಂದರೆ NS2 electrons are not available, hence they show only +1 oxidation state. Okay, so this is the answer for your assignment, question paper number 2, question number 7. Next, we'll see the dimeric structure of AlCl3. Okay, this is the structure. Actually, AlCl3 is found in a dimeric structure. AlCl3 ಅದೇನಾಗ್ತದೆ, ಮತ್ತೊಂದು AlCl3 ಮಾಲಿಕ್ಯೂಲ್ ಜೊತೆ ಡೈಮರೈಸೇಷನ್ ಆಗಿ ಇಟ್ ಫಾರ್ಮ್ ಅ ಬ್ರಿಡ್ಜ್ಡ್ ಬಾಂಡ್ ಬಿಟ್ವೀನ್ ಅಲ್ಯೂಮಿನಿಯಂ, ಕ್ಲೋರಿನ್ ಆ್ಯಂಡ್ ಅಲ್ಯೂಮಿನಿಯಂ. ಸೊ ಈ ಬಾಂಡ್ಗೆ ಏನಂತ ಕರಿತೇವೆ? This bond, this aluminium, chlorine, aluminum, or this one, aluminium, chlorine, aluminum, this bond is called bridged bond. Okay, so bridging bond anta kariteve. One molecule of aluminium trichloride AlCl3 forms a bridged bond with another molecule of AlCl3, forming a dimeric structure. ಯಾಕೆ ಅಂತಂದರೆ, in a trivalent state, +3 state, no, most of the compounds are covalent in nature. Being covalent, they undergo hydrolyzation in water. Therefore, this aluminium, no, adu ಏನಾಗಿಬಿಡ್ತದೆ, in acidified aqueous solution undergo hydrolyzed, forming AlH2O 6 times 3+. Okay, so in order to achieve the stability, it form a dimeric structure. ಹೈಡ್ರೋಲೈಸಿಸ್ ಆಗಬಾರ್ದು, ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್ ಹೈಡ್ರೋಲಿಸಿಸ್ ಆಗಬಾರ್ದು ಅನ್ನೋದಕ್ಕೆ ಅದೇನು ಮಾಡ್ತದೆ, ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ಲೋರೈಡ್ ಬ್ರಿಡ್ಜ್ಡ್ ಬಾಂಡ್ನ ಫಾರ್ಮ್ ಮಾಡಿ ಡೈಮರೈಸೇಷನ್ ಆಗಿ ಅದು ಸ್ಟೇಬಲ್ ಆಗಿ ಉಳಿತದೆ. ಇಲ್ಲಾಂದರೆ ಡೈಮರೈಸೇಷನ್ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಇಟ್ ವಿಲ್ ಅಂಡರ್ಗೋ ವಾಟ್? hydrolyzation reaction. So this is the dimeric structure. Again, this structure is very important. The model question paper number 1 ಏನು ನಿಮಗೆ ಅಸೈನ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದೇವೆ ಬರೀಲಿಕ್ಕೆ, ಅದರಲ್ಲಿ question paper number 1 question number 8 is like this: write the dimeric structure of AlCl3. You need to draw this structure. Okay, fine. Next concept, some important trends and anomalous properties of boron. We have studied anomalous property concept in a S block elements lesson. Anomalous behavior of lithium in case of group number 1, anomalous behavior of beryllium in case of group number 2 we studied. No, so anomalous behavior andre the property of the first member of the group will be somewhat different from the properties of rest of their members. So ಏನಂತೇವೆ anomalous behavior ಅಥವಾ anomalous property, anomalous trend ಅಂತ ಕರಿತೇವೆ, abnormal trend ಅಂತ. Here, which is the first member of the group? Boron. The property of boron is somewhat different from the properties of rest of the members. Okay, so aluminum, gallium ಉದಿದೆಲ್ಲ ಎಲಿಮೆಂಟ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಬೋರಾನ್ ಪ್ರಾಪರ್ಟಿ ಒಂದು ಸ್ವಲ್ಪ ಬೇರೆನೇ ಇದೆ. ಅದಕ್ಕೇನಂತೇವೆ ಅನಾಮಲಸ್ ಬಿಹೇವಿಯರ್. What's the reason? So reason is boron having very small size in its atomic as well as in ionic state. Okay, so boron size is exceptionally small, hence it show anomalous behavior. And boron, down the group ionization enthalpy decreases. Highest elide boron. Boron has higher ionization enthalpy due to small size, and there are no d orbitals in case of boron, absence of d orbitals. Aluminium, gallium, indium ಉಳಿದೆಲ್ಲ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ d orbitals ಇದೆ. ಓಕೆ, ಅಫ್ಕೋರ್ಸ್ ಅಲ್ಯೂಮಿನಿಯಂದಲ್ಲಿ d orbital ಇದೆ, ಫಿಲ್ ಆಗಿಲ್ಲ. ಗ್ಯಾಲಿಯಂ ಆನ್ವರ್ಡ್ಸ್ ಎಲ್ಲ ಫಿಲ್ ಆಗಿದ್ದಾವೆ. ಅಂದರೆ ಅಲ್ಯೂಮಿನಿಯಂ ನಂತರ ಇರೋ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಇದೆ, ಆದರೆ ಬೋರಾನ್ದಲ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಇಲ್ಲ, ಅಬ್ಸೆನ್ಸ್ ಆಫ್ ಡಿ ಆರ್ಬಿಟಲ್ಸ್. ಹೆನ್ಸ್ ಬೋರಾನ್ ಶೋ ಸಮ್ ಅನಾಮಲಸ್ ಬಿಹೇವಿಯರ್ಸ್. ಯಾವ್ಯಾವುದು ಪ್ರಾಪರ್ಟೀಸ್ ಯಾವ್ಯಾವುದು ನೋಡೋಣ. Because of anomalous behavior, boron show maximum covalency of only 4. Because of what? Absence of d orbital, boron covalency is maximum of 4. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ತೋರಿಸೋದಿಲ್ಲ. Whereas aluminum and other elements, aluminum, gallium, indium, thallium, their covalency can be expanded beyond 4. ನಾಲ್ಕಕ್ಕಿಂತನೂ ಜಾಸ್ತಿ ಇರ್ತದೆ ಅದರ covalency. ಯಾಕೆ? Other members have d orbitals. Due to the presence of d orbitals, their covalency is more than 4, whereas boron covalency is maximum 4. ಹಾಗಾದ್ರೆ ಬೋರಾನ್ ಪ್ರಾಪರ್ಟಿ ಉದೆಲ್ಲ ಎಲಿಮೆಂಟ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಇದೆ, ಹೌದಿಲ್ಲ? That's called as what? Anomalous property. And boron, the trichlorides and tribromides, triiodides of boron are aqueous, exist in aqueous medium. Okay, aqueous state ಅಲ್ಲಿ the boron, trichloride, tribromide, triiodide exist, whereas other members trichloride, tribromide and triiodides, they exist, they are in a covalent nature and they undergo hydrolysis in water. Okay, so ಇಲ್ಲಿ ನೋಡಿ boron ಅದು trichloride, tribromide, triiodides, they exist in aqueous state, whereas other members trichloride, tribromide and triiodides do not exist in aqueous state. In aqueous state they undergo hydrolysis. Okay, so you can ಅನ್ಬೋದು the anomalous behavior of boron, reasons and properties. Okay, again the model question paper number 2 assignment ಕೊಟ್ಟಿರೋ paper 2 ದಲ್ಲಿ chemistry part B question number 15 is like this. Write any two anomalous properties of boron for 2 mark. Okay, so ಈ ಪ್ರಾಪರ್ಟೀಸ್ ನ ನೀವು ಬರಿಬೇಕು for 2 mark. Okay, fine. We'll see the last concept of in this study of group number 13, uses of boron and aluminium as well as their compounds. Okay, ಸ್ವಲ್ಪ uses ನೋಡೋದಾದ್ರೆ boron used in a preparation of boron fibers. These boron fibers are used in making bulletproof vest, bulletproof jackets, which are used by these military soldiers. Soldiers, they use bulletproof jackets. They are made up of boron fibers because boron is very hard in nature and very light in nature and light composite material for aircraft. Okay, boron fiber is used in a aircraft material as well as in the preparation of bulletproof vest. One of the isotope of boron, boron 10, is used in a nuclear reactors as a control rods. The compound of boron, it's a borax and boric acid. are used in the manufacture of glasses like Pyrex glasses. They are called as heat resistant glasses. In those preparation, the compounds of boron like borax and boric acids are used. This borax, white colored crystalline powder, which is also used as a preparation of medicinal soap. It act like a constituent of medicinal soaps. Another compound of boron, it's orthoboric acid. In its aqueous state, in aqueous solution, orthoboric acid act like a mild antiseptic. Okay. So antiseptics are the chemicals, they are the medicines which are used to kill the microorganisms. Okay. In those aqueous state, the boron compound orthoboric acid behave like a very weak antiseptic, mild antiseptic. Whereas the other element of the group, aluminium, forms alloys mainly with copper, manganese, magnesium, silicon and zinc. Alloy is a blend of two or more metals. Alloys ಏನಂತ ಕರೀತೀರಿ ಕನ್ನಡದಲ್ಲಿ ಮಿಶ್ರಲೋಹ ಅಂತ ಕರೀತೀವಿ ಹೌದಾ. ವೆನ್ ಟೂ ಆರ್ ಮೋರ್ ಮೆಟಲ್ಸ್ ಆರ್ mixed together, blended together, we get alloys. Aluminium forms alloy with copper, aluminium forms alloy with manganese, magnesium, silicon as well as zinc. Aluminium and their alloys can be used in different material preparation because these alloys they given shape of a pipe, they given shape of a tubes, rods, wires, plates, foils, etc. Okay, so ನಮ್ಗೆ ಯಾವುದು ಡಿಸೈರ್ಡ್ ಶೇಪ್ ಬೇಕೋ ಆ ಶೇಪ್ನ ಕೊಡ್ಬೋದು. ಪೈಪ್ ಆಗಿ, ಟ್ಯೂಬ್ ಆಗಿ, ರಾಡ್ ಆಗಿ, ವಯರ್ ಆಗಿ, ಪ್ಲೇಟ್ ಆಗಿ, ಇವನ್ ಫಾಯಿಲ್ ಆಗಿನೂ ಯೂಸ್ ಮಾಡ್ಬೋದು. ದೇರ್ ಫಾರ್ ದೀಸ್ ಅಲ್ಯೂಮಿನಿಯಂ as well as their alloys are used in packing industry, utensil making industry, then construction industry, aeroplane material preparation as well as in a transportation industry. These are very few uses of boron and aluminium. Okay, so with this we completed the study of group number 13 elements. Okay, so ಇದ್ರ ಜೊತೆಗೆ boron compounds like orthoboric acid, borax, diborane are there in your textbook, but that concept is deleted from the syllabus. Okay, so this much is enough for the reduced syllabus concept. In the next class, I'll begin with the next group number 14, that is carbon family. Thank you.